Hello, everyone. Welcome back to the Cases for Crisis, Equipping Sterile Processing and Surgery to Succeed in ASCs. My name is Lisa McCown from the Beyond Clean team, and I'd like to thank you for joining us. I'd also like to thank our sponsor, 3M, for their support in bringing this conference to you today. There is a question and answer tool at the left-hand side of the screen toward the bottom. You can submit any questions that you may have for the speaker throughout the presentation. And those questions will be answered at the end of the live question and answer portion of the presentation. And we did want to let you know that this session will be live audio only. All right, so Susan Flynn is a technical applications specialist with 3M. And today Susan is going to discuss quality control practices for tabletop sterilizers and best practices for sterilization documentation. Without further ado, let's welcome Susan Flynn.
Hey everybody, thanks so much for tuning in to the session today. As Lisa said, my name is Susan Flynn, and my assignment today was to talk about sterilization quality control in the clinic setting. I also wanted to give a shout out to Lindsay and Lisa and the Beyond Clean team for organizing this event, and to 3M for sponsoring it. By way of disclosure, I wanted to mention that I am a technical application specialist at 3M Company. I work for 3M as an application engineer in our device reprocessing business, and I'm located in St. Paul, Minnesota. If any questions come up today that we don't have time to get to, I'd like to invite you to call our sterilization tech line. We're happy to address both product and practice questions at your convenience. So that's who I am, and I'm curious to know who's listening. If you wouldn't mind sharing, do you work in an independent medical or dental clinic? Perhaps you work in a clinic that's part of a larger healthcare system, or work in an ASC that's today's target audience. Or maybe you work in a hospital system but have oversight over clinics. So if you wouldn't mind just responding, that will help us understand who's participating right in this session. Okay, let's see our response. Okay, a few of you are in independent clinics. Some of you are part of a larger system. Almost 30% work in an ASC, and then many of you have oversight over the clinics. Yeah, we talked to all of these situations, so thank you so much for joining and for responding to that poll. Our learning objectives today are to discuss steam sterilization monitoring tools, and we want to review the quality control practices recommended in AAMI ST79 with a particular focus on those for tabletop sterilizers. And then we also want to talk about the documentation considerations associated with sterile processing in the clinic setting. So those are our learning objectives for the day. But before digging into that, I wanted to reflect on the critical role you all play in stopping the disease transmission cycle. This slide depicts the familiar chain of infection, something that, because of COVID, we're all very familiar with. But if we think of the context of instruments used in a procedure, starting at the top and working our way clockwise, an infectious agent could be hosted in patient A, who acts as the reservoir, and a procedure performed at your clinic or surgery center could provide the portal of exit for that infectious agent. Then the reusable instruments used during the procedure could potentially serve as the vector, providing a mode of transmission for that pathogen to infect patient B, a susceptible host, when they're used in the next procedure. So your work in sterile processing helps to break this chain of infection. And by carefully cleaning and then sterilizing or disinfecting reusable instruments, the disease transmission cycle is broken, helping to prevent surgical site infections caused by inadequately reprocessed instruments. So this is a concern we've had for a long time, but we were surprised. I don't know if you guys saw this late last year. Are you familiar with ECRI? It's the Emergency Care Research Institute, and I kind of think of it like a Consumer Reports for healthcare. Late last year, they published their annual list of, hey, what are the top 10 technology hazards for 2020? And I should mention that this list was published pre-COVID-19, so they did not have visibility to that huge issue coming down. But we were surprised to see that infection risks from sterile processing errors in medical and dental clinics made it to number 3 on ECRI's list. So while sterilization is critical to breaking that disease transmission cycle, errors in device reprocessing may mean that instruments are not appropriately processed. ECRI had a couple of key safety measures in their write-up, and that included designated a qualified staff member or contractor to support infection control practices at the office, and to provide appropriate training and to conduct periodic competency testing for the individuals operating tabletop sterilizers. So for those of you part of large systems, probably not an issue. For those of you who work in a smaller clinic setting, how do you make sure that you've got that oversight and that somebody is assessing competency? Just something to think about. Some of you that are listening here in the United States may be accredited through the Joint Commission. There are many accreditation bodies. Joint Commission is one of the big ones, especially for those people that are associated with acute care networks. But most surveyors, no matter which accreditation body they're associated with, are very interested these days in instrument processing. And in a blog post published just recently in September, Joyce Webb of the Joint Commission shared information about the 10 most challenging standards in the ambulatory care settings for all of last year, for 2019. And it was no surprise, because this has been pretty consistent, that IC 0202 or 01, which is the infection control standard in Joint Commission that states that the organization should reduce the risk of infections associated with medical equipment, devices, and supplies, was once again at the top of the list. Now, the blog post did share some compliance tips that I wanted to pass along to you today, and this includes to make sure that you're reviewing manufacturers' guidelines for using disinfectants and cleaning products and operating equipment such as ultrasonic cleaners and sterilizers. You should also ensure that all staff receive education and ongoing competency assessment, so back to the same theme mentioned in ECRI, in cleaning, disinfection, and sterilization processes, and that you're reviewing quality control activities associated with those processes. So just checking your quality control logs. Is anyone doing that on some frequency to monitor compliance? Another tip was to self-assess your process for adherence to those manufacturers' instructions for use, evidence-based guidelines, and your clinic's own policies. So the reference is at the bottom of the slide in case you want to dig in and read the entire blog post. So today's focus is on steam sterilization and sterilization monitoring in the clinic setting in this particular session. But I wanted to ground our conversation with a few basic definitions first. Let's think about cleaning. What does cleaning achieve? Cleaning is the process for removing organic soil. In your clinic, you may use manual cleaning. You might have an ultrasonic cleaner, especially folks in the dental clinics tend to have ultrasonic cleaners. Or if you're at a larger ASC or in a hospital, you probably have automated washers. After cleaning, you can expect a low level of microorganisms to still be present on the instruments, so you still need to consider them infectious. If we move to the middle bucket, disinfection, that's a process used to destroy microorganisms using cleaning disinfectants, using chemicals. Disinfection is less lethal than sterilization and typically does not kill all bacterial spores. So the even high-level disinfection process by definition, is not required to kill all bacterial spores. So while disinfection is appropriate for items that touch intact skin or disinfecting surfaces and equipment in your clinic, it's not effective for critical items. Then moving over to sterilization, the sterilization process, by definition, destroys all microorganisms, including bacterial spores. So sterilization of critical instruments is a very important step in your clinic's infection prevention process to help minimize patient-to-patient disease transmission, going back to breaking that chain of infection. One of the resources you'll hear me lean on today is AORN. So the Association for Operating Room Nurses publishes a great guideline for perioperative practice. Within that, there are several sections that are pertinent to device reprocessing, including their guideline for sterile technique. And if you think back to the Spalding classification scheme that tells us that critical devices are defined as instruments that enter sterile tissue, including the vascular system. And AORN reminds us we're setting up a sterile field for each procedure that's invasive, and critical devices that are used should be sterilized between patients. So in your clinic, as you prepare sterile fields for patient procedures, remember that AORN's guideline for sterile technique states that only sterile items should come into contact with that sterile field. And the most common way that reusable items are sterilized in clinics is using steam sterilization. And in fact, both the CDC and AORN recommend that saturated steam under pressure should be used as our go-to sterilant for devices that can tolerate the heat and moisture inside a steam sterilizer. So unless otherwise indicated by the device manufacturer, steam sterilization should be your go-to method of sterilization. And that's because steam under pressure is able to transfer large quantities of energy really quickly, killing the bugs in relatively fast cycle times. So we know it's an effective, economical, and efficient method of sterilizing our load items. The technology has been around for over 100 years, so it's very well understood. It's easy to use. Our load items can be packaged, meaning that they can remain sterile once they come out of the sterilizer. And thankfully for people using steam sterilizers, there are no hazardous residues once the sterilization cycle is complete. Now, some of you maybe listened to earlier presentations today, and you might have heard us talk about the concept of critical variables. Every method of sterilization has critical process variables that are required to achieve an effective sterilization process. In the case of steam sterilization, there are 3 critical variables, and I'll give you a moment to reflect on what they are. Okay, hopefully you got them. In the case of steam, the variables are time, temperature, and the presence of saturated steam. If any one of these variables is missing, then the cycle may not be effective, meaning the devices might not be sterile. And while you probably check time and temperature on your printout, remember that saturated steam, which is water vapor in a state of equilibrium between condensation and evaporation, is our sterilant. And we need that saturated steam to come in contact with all load items. So good steam quality is essential. So while our critical variables are time, temperature, and the presence of saturated steam, we've got an enemy to effective steam sterilization, and that is air. We need that steam to be able to contact the devices, and to do that, we need to get the air out of the chamber and out of those load items. So typically, after you press a start button on a steam sterilizer, there's a conditioning phase. During this conditioning phase, the air is removed, And there are a couple of different common methods of air removal. Tabletop sterilizers typically rely on one air removal method, but there are a couple of devices that have multiple processes built into them. And those common methods of air removal are gravity displacement, where incoming steam simply drives air out the chamber drain, and there's dynamic air removal. It's an umbrella bucket where, as the name implies, there's active air removal. It might either be pre-vacuum, where there's a series of vacuum and pressure pulses removing the air, or the steam flush pressure pulse system, or SFPP, where positive pressures of steam kind of alternate with gravity flushes. So gravity and dynamic air removal. I wanted to talk about each of these processes in a little bit more detail. So on this slide is a graphic representation of the gravity displacement cycle. The dotted line represents atmospheric pressure, so our pressure in the room, and the graph shows pressure as a blue curve as a function of time as we go through the sterilization cycle. And you can see after we start that cycle, the pressure starts building in the chamber as incoming steam displaces the air through the drain that's located typically in the bottom of the sterilizer. And we call this the conditioning phase. When the temperature sensor in the drain senses that the chamber has reached the pre-selected temperature, say 270, typical temperature that many of you probably use, then the drain closes and the actual sterilization phase begins. So when we talk about the exposure phase or sterilization phase and ask how long is that, that's the time we're looking for. Not the entire cycle time, but how long are instruments actually exposed to saturated steam at the right temperature. How long is that cycle, exposure time? And then, of course, we finish with a drying phase. So let's contrast that, look at this picture of a gravity cycle with what happens in a pre-vacuum cycle. So again, we have a graphical representation of pressure during a pre-vacuum cycle, and the blue line depicts chamber pressure as a function of time. And you can see that during the conditioning phase, air is mechanically removed. So steam is injected, and then steam and air are sucked out of that chamber, and it actually drops below the dotted line, meaning you're pulling a vacuum. You're going below atmospheric pressure. And during the conditioning phase, there's a whole series of vacuum pulls that very effectively remove the air from the chamber and from the lumens and complex geometry of load items. And then a drying phase at the end helps ensure that the load is dry. Another type of dynamic air removal is steam flush pressure pulse. So in this graph, we have a green line showing the temperature in this chamber, and then kind of that purple curve showing the pressure, again, as a function of time, this time in a steam flush pressure pulse sterilizer. So just like in dynamic air removal, you can see steam flushes and then kind of pressure pulses, but it never drops below atmospheric pressure. So that's the difference between a pre-vacuum and a steam flush pressure pulse. Many tabletop sterilizers now employ steam flush pressure pulse sterilization cycles, as it offers a more efficient method of air removal than a simple gravity sterilizer would have. Another term you may sometimes hear is terminal sterilization. And you might wonder, what the heck is that? And that simply conveys that the load items are packaged prior to sterilization, so they can be put on the shelf and stored until you need to use them. So when you think about the packaging attributes, of course, they may allow air removal and steam penetration during the sterilization cycle, and then during storage, they need to provide a microbial barrier so that the sterility of that sterilized item is maintained until use. And speaking of that sterility maintenance, most facilities follow an event-related concept. And that means that you would consider an item that has been terminally sterilized to be sterile until an event, like, for example, the package getting torn or the item getting wet, compromises the sterility of that item. Okay, staying with terminology, let's talk about immediate use steam sterilization, or IUSS. And as the name implies, immediate use steam sterilization is a process designed for steam sterilization of patient care items for immediate use. So they're going straight from the sterilizer, aseptically transferred to the sterile field. And well, in the past, this was largely used to quickly reprocess an instrument, say, that was dropped mid-procedure. Over time, it was abused and used too frequently, sometimes used to sterilize whole sets for not a very good reason. And the sterilization cycle itself, the IUSS cycle, is of course effective, but surveyors observed that shortcuts were being taken in how the items were cleaned and prepared and packaged for sterilization. So thankfully nowadays we have a really good consensus in our industry, and the consensus includes the concept that IUSS is only done in urgent clinical situations. There's little or no dry time, meaning the item cannot be put up for sterile storage. The item should be placed in a container that's validated for IUSS, and you're running the cycle parameters that the container has been validated for. And finally, with IUSS, we still see both gravity and dynamic air removal cycles being used, with a real trend, I would say, over the last 10 years or so, we've seen a shift to the use of containers for IUSS, closed containers, because that's what both AAMI and AORN recommend, and also the use to the more efficient method of air removal, to dynamic air removal, specifically pre-vacuum cycles. And then I just wanted to review as well the definition for tabletop sterilizers. I'm sure many of you that do work in the clinic setting have a tabletop sterilizer, maybe like one of the ones on the screen, and you really rely on these puppies. I know in the dental setting, these guys are working all day long, back-to-back, running cycles. ST79 describes a tabletop sterilizer as a compact sterilizer having a chamber volume of less than 2 cubic feet that generates its own steam on board. So typically the user adds distilled or deionized water to the chamber. And this is in contrast, just so you know, to large in-wall sterilizers found in hospitals and in some surgery centers that are connected to a hospital boiler that may be quite a distance from where the sterilizer is located. And whereas years ago, tabletop sterilizers were mostly gravity sterilizers, nowadays there are many choices available. There are many manufacturers, and they all offer a variety of choices. So you might have a gravity sterilizer, or you might have one that uses a dynamic air removal method, such as pre-vacuum or steam flush pressure pulse. And that takes us to our next polling question. At your clinic, what method of steam sterilization are you using? What specific process are you using? Do you do terminal sterilization using gravity cycles? Terminal sterilization using pre-vacuum? Perhaps you use SFPP? Maybe you use unwrapped sterilization in your tabletop sterilizer, and maybe you use IUSS, either gravity or pre-vacuum. So I'll give you a moment to vote. Okay, let's see. Oh, just under 20% are doing gravity. About 62 doing pre-vacuum. A few of you have SFPP. And we do hear about this unwrapped in tabletop sterilizers. I do talk to folks using sterilization by the unwrapped method. Always a bit of a concern, because then you don't have a terminally sterilized item. As soon as you open that sterilizer door and remove the item, it becomes potentially contaminated, so you wouldn't want to use that device as a critical item. And then in terms of pre-vacuum, good to see that people are indeed using pre-vac. So probably one of the most critical items to a clinic safely processing instruments is knowing if you're running the correct sterilization cycles for the devices that you have in your clinic. This is a concept that is very well understood in hospitals, so they are very tuned into that. And in the clinic setting, I would say we're just starting to have a better understanding of that. So those of you that are part of a larger health system probably are familiar and may even be able to tap into the hospital's online repository of or subscription to IFUs from various manufacturers. Those of you in smaller clinics, this might be something you wonder about. Well, how do we know we're running the right cycle? And of course, the way that you know is by consulting the device manufacturers' validated instructions. So in their instructions for use, they will provide instructions on how to clean, package, and sterilize those load items. And so when a manufacturer makes a new device, it is their responsibility, and it's actually part of their package that goes into the FDA to get clearance to sell that product. They have to show the FDA that they understand for reusable devices that it can be cleaned and that they have validated a method of sterilization. So that's the responsibility of the device manufacturer. You, working at a healthcare facility, have the responsibility to make sure you have those written instructions from the manufacturer. And AORN provides some good guidance on this, and they say, hey, you got to make sure that you know how to clean, what cycle type, what's the exposure time and temperature that you should be running for this particular item. This is an item that surveyors, as we saw from that Joint Commission slide, are also very tuned into, and they expect the frontline staff that's performing the work to have access to those manufacturer IFUs. Now the tricky part, and I truly feel sorry for you guys on the front lines having to deal with this, but AORN does say that if you have a conflict between the device, sterilizer, and perhaps packaging IFU, it's on you as the end user to reconcile that difference. So I understand that this is truly a burden and does require some legwork. And our survey bodies also understand that. And so I mentioned that blog post from the Joint Commission on the top 10 noncompliance issues in the ambulatory care setting for 2019. In this blog post, Joyce Webb of the Joint Commission did share some advice on this topic of, of reviewing the sterilization parameters for each device. If there is a mismatch, she has some practical tips. First step, she said, hey, contact the device manufacturer to see if the cycle that you have available is acceptable. They might be able to provide you something in writing that indicates it is. Maybe you can contact the sterilizer manufacturer and reprogram the sterilizer to run a cycle that matches the device IFU. If neither of those two options are possible, perhaps you look at using a different device or having to purchase a new sterilizer. So on that note, a word of advice, hopefully you're already very involved. If your clinic or surgery center is looking at buying new instruments, make sure you're in on that conversation, and that one of the considerations is, do we have the right equipment to be able to reprocess the device, to be able to clean it as recommended by the manufacturer, and to sterilize it according to the validated method of sterilization provided in the manufacturer's IFU. So related to that, but this time talking more about the sterilizer, I wanted to touch on another responsibility, and that is to load that sterilizer as recommended in the sterilizer manufacturer's user manual or operator's manual. Again, something hopefully that is available to frontline staff. And you want to think about loading, because we talked about the fact that those critical variables need to be present, and we need to get the air out of the way, right? So proper loading will help facilitate air removal from the chamber and the load items, allow steam contact with all those load items, and then facilitate drying at the end of the cycle. You want to look at the manual to see if they specify the total weight or number of packages that have been validated for each cycle, and really resist. I know it's tempting to overload these small chambers, but do pay attention to any weight restrictions, and also be sure to orient the paper plastic peel pouches as recommended in the Sterilizer user manual. And I really like the holders, like the one on the bottom shelf and the picture on the right, that keep peel pouches nicely spaced. So that takes us to our next learning objective of talking about our available sterilization monitoring tools. So sterile is defined as the absence of all viable microorganisms. The goal of the sterilization process, of course, is to kill any bugs that might still be contaminating your cleaned instruments. However, you can't see or inspect that sterilization process. You can't tell by looking at a device whether or not something is sterile. And we therefore rely on a suite of monitoring tools, because what we want to do, oh, and I apologize, this slide is messed up, is gather information about the process to demonstrate that it was effective. So the tools at our disposal are biological indicators, and you might hear me say BIs, which contain live bacterial spores. They can demonstrate the lethality of a sterilization cycle. We also use chemical indicators. Chemical indicators might turn color, or there might be an ink moving front that migrates up into an accept region, and they help determine where they are placed in the sterilizer and in the package that sterilant got there. And finally, there are physical monitors, so the gauges or printouts, or nowadays maybe a USB device on the sterilizer itself. And evidence from each of these tools helps us know whether the sterilization process was effective and to make a good decision about whether to release a particular load. And conversely, if any of the monitoring tools indicates a problem with the sterilization cycle, then you would not release the load. So let's dig in a little bit, talking about physical monitors first. So by that we mean the way that the onboard sensors in the sterilizer are communicated to you, the user. So there might be sensors looking at temperature and pressure in the chamber that are provided on a printout, and they help confirm that the correct cycle was selected, and they also provide a record that you ran the correct cycle. Then if we talk about chemical indicators. Chemical indicators are defined as devices that are used to monitor presence or attainment of one or more of the parameters required for a satisfactory sterilization process, and they're used in specific tests. There are three buckets of chemical indicators. Exposure indicators that help us distinguish process from unprocessed load items. They're placed externally on every pack, of course, to verify exposure to the process. Internal chemical indicators that go inside each peel pouch or wrap tray or rigid container to verify that our sterilant got there. And then the special test bucket, such as our daily Boyd-Dick test. And we'll talk about each of these in more detail later on. Just like you guys have to be aware of standards, so too people who manufacture chemical indicators, like my employer, 3M, we have to comply with international standards. So in particular, for chemical indicators, there's an ISO standard, an international standard 11140 Part 1, that provides performance specifications for chemical indicators. This standard details 6 types of CIs based on the characteristics and intended use of the indicator. So basically, each type of CI has its own job to do, and specific performance specifications laid out in that ISO standard. So when you first look at that list, you might think it's a hierarchy, but I wanted to share that ISO specifically says this is not the case. So it's not like a type 4 internal chemical indicator is more important than our type 2 Boyd-Dick test, which of course is critical to know that our PREVAC system is working correctly. So there are various types on the market. We'll talk about how those are used later in the presentation, but know that those types come from an international standard, and when you're buying chemical indicators, you should check that the manufacturer complies with the requirements of that standard on their labeling. And finally, that takes us to our third element, biological indicators. Biological indicators contain a large number of viable microorganisms, and they're not just bugs, but they're in the spore form. And so some of you may know that microorganisms in the spore form are kind of like a nut in a shell. They're very resistant to disinfectants and chemicals and sterilization methods. And so if you can knock out this large population of resistant spores, then you can be pretty confident there's a high probability that any microorganisms that might have been contaminating your clean instruments have also been inactivated. That's kind of the premise of a biological indicator. They're available in several formats. Some of you working in clinics might be familiar with the glassine envelope that has a paper strip coated with spores. Those of you working in hospitals, and probably most clinics and ASCs, are more familiar with the self-contained biological indicator format. In this format, which was introduced way back in the 1970s, you've got your spore carrier, where the spores are coated into a paper strip or some sort of plastic carrier, and then right along with that is a vial of growth media designed to support growth of that particular organism. It's all contained in an outer vial, making it easy to incubate it right in the clinic. You don't need to send it out to a microlab for incubation. So biological indicators are the only monitoring tool that demonstrate the lethality of the sterilization process. And biological indicators aren't used just on their own typically. So just like most of you were doing terminal sterilization where your load items are contained or wrapped somehow, similarly, we put the BIs inside a process challenge device, and that's designed to mimic the challenge posed by packaging to the sterilization process. There are both user-assembled process challenge devices, and those are typically used for tabletop sterilize. We'll talk about that more in detail later on. And then there are pre-assembled, commercially available PCDs, having the advantage, of course, of being made in a factory, very consistent, standardized challenge. These are typically used in the large sterilizers found in hospitals and surgery centers. So now that we've talked about what those monitoring tools are, I wanted to review the quality control practices recommended in AAMI ST79. And because this session is supposed to be for folks in clinics, we'll pay particular attention to what does it say about tabletop sterilizers in ST79. So the two main sources of resources for the standards and recommendations I'm stating, of course, are coming from AAMI ST79 and the Guideline ST79, it's a standard actually, it's a national U.S. standard, and it is applicable to steam sterilization in all healthcare settings. So whether you work in a large acute care facility, at an ASC, or in a smaller medical or dental clinic, AAMI ST79 is your go-to document for steam sterilization and monitoring recommendations. I do sit on the committee that writes this document, and they really do take pains to be inclusive of all the different care settings where steam sterilization is done. Another reference, as I mentioned before, you'll hear me talk about, is AORN. They have their Guideline for Perioperative Practice. They publish it every year, and every year a handful of the standards within it are updated, and so they do a great job at AORN of making sure their guidelines are evidence-based. They do a careful literature review and making sure they're evidence-based guidelines. In ST79, there are 4 levels of testing described. So if you have a copy, where you want to go is Section 13, and it can be a little overwhelming, so if you just take a step back, high-level view, know that there are 4 levels of testing. The first is routine release testing. Every time I run a cycle, how am I making that decision about whether to release those load items for patient use? The next is routine sterilizer efficacy monitoring. What is my routine pattern for making sure this big piece of hardware I have, the sterilizer, is working properly? How am I doing that? Then there's sterilizer qualification testing. That testing that we do after sterilizer is newly installed or has a major repair to make sure that in our clinic or surgery center with our water or steam supply, that vessel is working properly. And then periodic product testing. That's a concept that you take an item that you routinely sterilize and make sure that with your packaging, your sterilizer, that you're getting good results. So in this session, we're focusing only on the top 3, and these are what I do see very well practiced across the country. So first, routine load release. I've run a cycle. How do I decide whether to release that load? And again, we rely on kind of that 3-legged stool of monitoring. The printout, so the physical monitors, my chemical indicators. I've got an external indicator, a type 1 indicator on every package, and an internal indicator, and AAMI does say preferably a type 5 or 6 internal chemical indicator inside every package. And then for non-implant loads, it's optional about whether you would use a process challenge device or PCD. If you do use one, it might be a BI only. You might use one with both a biological and a type 5 chemical indicator, or you might use a PCD that contains just a type 5 or type 6 chemical indicator. All of this data should be assessed by somebody who knows what they're doing, somebody who's competent and trained, and then if anything indicates there was a sterilization process failure, you would, of course, not release the load. Kind of, if in doubt, throw it out is the mantra. By physical monitors, we mean that you should be checking the sterilization cycle printout after each cycle. Did you run the cycle you intended to? Most of these sterilizers have many programs available on them. Did you run the one you wanted to? And AAMI does say that sterilizers that don't have recording devices should not be used. And of course, nowadays, that might be that you've got an electronic transfer of the data. That's perfectly acceptable. So you need to have some method of checking the parameters, either a printout or through a USB or something. We talk a little bit about exposure indicators. So this is our external chemical indicators that are on every item. Can be indicator tape that does 2 things, keeps the bundle closed, and also is printed with ink to indicate exposure. On our containers, there might be a dot on the lock to indicate exposure, and they provide simply a visual confirmation that the load saw steam. And they are intended to prevent accidental use of non-processed items. And you know, it's sad, but almost every year we do hear a story where somewhere in the country a load item that never was sterilized is somehow given or taken and used in the OR. So external indicators, they're not real sophisticated. It doesn't take a lot to get them to change. They don't tell us much about the quality of the sterilization process, but they do that first line of defense and make sure we know whether something was sterilized or not. Then internal chemical indicators, they should be placed in each load item inside each tray. And I mentioned that AAMI now does recommend the use of a type 5 or type 6 internal chemical indicator. When I'm talking to people in hospitals and surgery centers, this is very routine and common practice. In clinics, I think we still have some room to get there. Some people rely on a pre-printed dot on a peel pouch, for example, as their internal chemical indicator. That dot is very unlikely to be a type 5 or type 6 chemical indicator, so probably not satisfying today's recommendations. And about the internal chemical indicator, of course, it's the responsibility of the staff in the OR or procedure room to retrieve and interpret that internal CI. So you want to make sure your colleagues know how to interpret the brand of CIs you're using. At small clinics, you might be the person scrubbing in, and so you, of course, know to check that chemical indicator. Now, AAMI and AORN, and in fact the CDC, they really place a higher level of importance on loads that contain an implantable device. And the FDA defines an implant, just so you know, as something that's going to stay in a natural or surgical cavity of the human body for more than 30 days. And the rationale, of course, is that because they're being left in the body, those implants present a higher level of risk. And so what's the difference in terms of how do we monitor loads that contain implants? Well, it's the text I have on the slide in red. For implant loads, you should include a PCD, process challenge device, that contains both a biological indicator and a type 5 integrating indicator. And you should quarantine that load until you have the results of the biological indicator. So surveyors really don't want to see premature release of implant loads, and really with the availability of rapid readout BIs from a number of manufacturers, there's probably no excuse to be doing early emergency release unless you're a big trauma center and truly have an emergency. When you do have a document emergency and have to release a load item before having a BI result, you now have that type 5 integrator in the test pack upon which you can make a better decision. And you probably are aware that there is a recommendation that you would document that emergency release situation. So the next bucket, if you'll recall from that high-level breakdown after routine load release, is routine efficacy monitoring. How do I make sure my sterilizer is working well, and how often should I be doing that? In ST79, this is further subdivided into 3 sections, so you want to make sure you're in the right place. They talk about sterilizers larger than 2 cubic feet, tabletop sterilizers, and gravity displacement sterilizers. So that's going to take us to our next polling question. I'm curious, at your facility, how frequently do you monitor your steam sterilizers with a biological indicator? Monthly, weekly anytime you do an implant, daily plus implants, or perhaps you monitor every load? Okay, let's see our poll results. Okay, I see a mix here. About 14% are weekly. I suspect that's folks working in clinics. Weekly plus implants at 4.8%, daily plus implants 33%, and every load monitoring at 47.6%. So this is pretty typical. I would say when we talk to audience that is just in hospitals, it'd be a mix of just those bottom 2 options, daily plus implants and every load monitoring. If we were at a live event over the break, you could network, check with your peers. So I wanted you guys to have a chance to benchmark what are other folks doing by sharing this slide. Good to see nobody is monthly. As we'll see later, that's not compliant with our recommendations. So this concept of routine sterilizer efficacy testing. How do I do it? With biological indicators, right? I make sure my sterilizer is working by demonstrating it's able to kill that large population of resistant bugs. In the case of steam sterilization, the organism we use is Bacillus steratomophilus. The same organism is used to monitor vaporized hydrogen peroxide sterilizers. You want to make sure that you select a biological indicator that's suitable for the sterilization cycle you're running. So remember earlier we talked about gravity, pre-vacuum, temperature, and exposure times. The FDA requires biological indicators to be validated and cleared for specific sterilization cycles. So make sure you're selecting a BI that's appropriate for your sterilizer. And it's important, that's one of the reasons it's important to know what cycles you run, not only so that you can run your instruments in the right cycles, but also so that you can choose a compatible biological indicator. As we mentioned earlier, those biological indicators are used within a process challenge device. So if you hear people talk about the term test pack or challenge pack or PCD, those are all synonyms for a process challenge device. For terminal sterilization, in large sterilizers, like the bottom picture on the right, the recommendation is to use a pre-assembled, commercially available PCD, and that product should, of course, be FDA cleared. For tabletop sterilizers, there are not commercially available PCDs available, so we'll see later that the burden then is on the end user to make their own representative PCD. Okay, I know many of you are in hospitals, so you probably have a large hospital with an in-wall sterilizer. Many of you in ASCs also have this type of sterilizer. So what you do is use either that AAMI towel pack, stack of 16 towels with a BI in the middle, or preferably, according to ST79, a commercially available disposable PCD that's equivalent in challenge to that 16 towel pack. And the PCD is placed the bottom shelf over the drain, and each cycle type that you have should be tested. So if you're running both 250 gravity and 270 prevac, for example, on your sterilizer, you'd want to be sure to test each cycle type. And the frequency recommended in AAMI ST79 is weekly, preferably daily. But as we saw in the poll, most folks do it daily plus implants if they're not testing every single load. If we look at dynamic air removal IUSS, and when we did that survey earlier, I think everybody said that was doing IUSS, that they're doing prevac. So now ST79 treats it just the same as your larger sterilizer in sterile processing. You use that pre-assembled, commercially available PCD. The only difference is they do give us the option of running that in an empty chamber. So some ASCs like to do that first thing in the morning, just test that prevac IUSS cycle with a PCD in an empty chamber. For anyone who had a gravity IUSS sterilizer, they are required to make a representative PCD. And they do that by placing the biological indicator and a chemical indicator in the type of rigid container that they use for IUSS, and then put that in an otherwise empty sterilizer. And then finally, I'm hoping today we have some folks from clinics here. In the clinic setting, you make your own process challenge device. And the concept is you want it to be representative of the way that you're packaging load items. So for example, if you're peel pouching items, you'd stick a biological and a chemical indicator and an instrument in a peel pouch, and that's your test pack or PCD. If you're using small metal cassettes that you wrap, you'd put the BIs in a package, wrap it, and label it on the outside, PCD. And I noticed in the survey, some of you did say you're doing sterilization by the unwrapped method. In that case, you would simply lay the naked BI and chemical indicator along with your unwrapped instruments on the tray and process the load. Your PCD should be placed in the area that's the cold point. And you probably want to check with the sterilizer manufacturer to see what they consider the cold point in their chamber. What's their recommendation for where to place it? When we're talking about monitoring, I can't not mention the need to run a positive control. Each day that you test your sterilizer, you want to be sure to also run a control BI. So that's a biological indicator that goes straight from the box into the incubator. And the purpose of that control is to make sure the bugs are alive. Am I testing my sterilizer with viable organisms? You want to make sure that the incubator is working at the right temperature and is able to detect a positive result. So some of you that may use maybe the older technology, just a color change, wait for that control media to turn yellow, indicating live microorganisms. Some of you with fancier auto readers rely on the auto reader to detect a positive result. And I want to mention that the test and control BIs should have the same lot number. Next, if we talk about routine efficacy monitoring, you need to consider the Bowie-Dick test. For those of you that do run pre-vacuum sterilizers, I mentioned that getting the air out of the sterilizer is so critical. We want to make sure that's effective by testing it each day before you run any load items with a Bowie-Dick test, which verifies the ability of the system to get air out of the chamber. So to make it an effective test, that Bowie-Dick test pack should be the only thing in the sterilizer chamber. I wanted to touch briefly on qualification testing. Not something you do often, so the only seed I want to plant in the back of your brain there is that, hey, this is a bit different, and there's guidance in ST79. And as I mentioned earlier, you do qualification testing after a major event. For example, you get a new sterilizer, or maybe you do a major repair on a sterilizer that you have. And when you do it, it's a sequence of 3 cycles. So for a large sterilizer, you run 3 cycles with a BIPCD and an empty chamber, 3 consecutive cycles, followed, if it's a pre-vacuum cycle, by 3 cycles of our Bowie-Dick test. In tabletop sterilizers, if you have a gravity or a steam flush pressure pulse, again, you'd run that representative PCD in 3 full loads. And of course, those load items need to be quarantined until the results are available. And for IUSS, similarly, 3 consecutive cycles. For pre-vac, make sure you run that Bowie-Dick test as well. I thought this would be another good question to benchmark, so I'd just like you to vote. In the last year, has your facility performed qualification testing on any of your steam sterilizers? Maybe you did because you purchased a new sterilizer. Maybe you had to after a major repair for another reason. Maybe you didn't need to, or maybe you didn't know you needed to. So I'll give you a few seconds to vote. Okay, let's see what the poll said. Ooh, well, hey, this is great, really great. 25% of you were lucky enough to get a brand new sterilizer and knew that you needed to qualify it before you put it into service. 75% of you had a major repair and knew that you needed to qualify your sterilizer after that. You know, sometimes in the clinic market, the tabletop sterilizers are small enough that they might actually go out for repair, and you might receive a loaner device, and you probably want to qualify that loaner before you start using it, and then requalify your sterilizer when it comes back as well. Thanks for sharing that. Great to hear that everybody's aware of the need to do qualification testing. I wanted to talk quickly about documentation considerations. In the clinic setting, this might not be done as carefully as it is in large hospitals, so be sure you're recording all the items on the screen. So you can just do a quick check to make sure you've got all those items being recorded. I also wanted to mention ST79 has a couple of amendments coming out later this year. One of the amendments, Amendment 4, is going to remind us to record both the lot number and the result for test and control BI. So I mentioned earlier, it's important to do that. For some reason, it's a survey or hot button. So, and it's going to be called out specifically in this section of ST79 soon. It's also going to mention for facilities that have multiple sterilizers, when you're doing your documentation, of course, you want to indicate which sterilizer the record pertains to. There is a section in ST79 about what do you do if you have a sterilization process failure. Say any of your monitoring tools indicate a failure. And it's important to remember that if you can't immediately identify the cause of the failure, you need to recall all load items back to the last negative BI result. And so avoiding having to recall and reprocess multiple days' worth of work is enough reason for many folks to monitor frequently. As we saw in the poll, about almost 50% of you were choosing to monitor every single sterilization cycle, and avoiding these recalls is a big reason that people choose to do that. Traceability, another perhaps opportunity in clinics to make sure that each item you process could be recalled. And you do that by placing a lot identifier on it that says, hey, this was done in sterilizer number 1, load number 2, here's what was in the load, and providing details back to the patient if it was immediate use. Maintenance records, just like you might have a file on your vehicle for all the maintenance, similarly you should be able to produce a maintenance record or log for every sterilizer at your clinic or surgery center. This could be in paper, electronic format, and it should provide a continuous history of all the maintenance that's done, whether it was scheduled or unscheduled service. So in summary, I wanted to compliment you and thank you for the work that you do to make sure that reusable devices are not a source of disease transmission between patients, because you guys are doing a super job and staying up on all the latest best practices when you're cleaning and sterilizing those load items. It's a really critical element of your clinic's infection control practices. Two things that you can do to ensure you're providing the best care is to make sure all staff has access and follows device manufacturer's instructions for use, both for the devices you're sterilizing and for the sterilizers you're using. And you want to make sure that your quality control procedures are based on current standards and guidelines. So great news is we've got our current references, AAMI ST79 and those ARN guidelines, both great sources of information. You don't need to invent this stuff. You can simply base your policies on those two resources. So thanks so much for your time today. I'm glad we had a chance to focus on sterilization and sterilization monitoring in the clinic setting. And I don't know, Lisa, do we have time for any questions, or how do you want to handle it?
It looks like we are right at time. So I'm going to go ahead and encourage everyone who has submitted questions to email Susan Flynn, and she'll be able to get in touch with you and answer those. So thank you everyone for joining us in this session. We're going to go ahead and take a short break, and we'll see you all in just a few minutes.